Good evening. Welcome to the Osher Lifelong Learning Institute at Berkshire Community College. My name is Carol Allman-Morton. I have a few short announcements and then we'll begin. With gratitude and humility, we acknowledge that those of us in the Berkshires are learning, speaking, and gathering on the ancestral homelands of the Mohican people, the indigenous peoples of this land. Despite tremendous hardship in being forced from here, today their community resides in Wisconsin and is known as the Stockbridge-Munsee community. We pay honor and respect to their ancestors past and present as we commit to building a more inclusive and equitable space for all. To learn more about programming at Ollie at Berkshire Community College, you can check out our website, berkshireollie.org. We have a number of programs coming up in the next month, especially in the next couple of weeks. So be sure to look at our calendar of events, berkshireollie.org/events. In particular, we have a distinguished speaker lecture on Monday on art and Auschwitz. And soon after that, I didn't put the date down in my notes, climate change and human migration. Also, tomorrow begins a 4-part series on 21st century medicine on Zoom, Wednesdays at 5:30 for the whole month of March. And very importantly, registration for our spring semester is now open and classes begin the first week of April. As we go along, if you have questions, please put them in the chat and we'll do our best to get to as many as we can. Josh is also planning to have a couple of pausing points to get some questions as we're going along. So let me introduce our speaker. Joshua Lake is the science department chair at the Pomfret School, and he teaches astronomy and coding classes. He also oversees the freshman engineering program, teaching computer and makerspace equipment skills. Josh's undergraduate study in astronomy launched his career in teaching science, and he earned his master's degree in learning and knowledge management systems, essentially teaching with technology. Josh helped install and calibrate the state-of-the-art telescope in the observatory at Pomfret, making it one of the top astronomical sites in the area, and brought hundreds of visitors to the observatory to see the bands on Jupiter, the rings of Saturn, and incredible views of the moon. And very importantly, which is why we have him here tonight, has been married to my childhood best friend for more than 20 years. So welcome, Josh Lake.
Thank you. Thank you all. Thanks for having me. And I'm just so excited to talk to you all about the coming total solar eclipse. But you mentioned my wife, Liz. I think she's out there. She got me this snazzy shirt, so I'll figure I'll show that right away. Twice in a lifetime. We did get to see the 2017 solar eclipse, and I'm looking forward to seeing this one as well. Hopefully more after that, but I think you have to take a cruise out into the ocean. Also, I like this t-shirt a lot. Big open check mark, so we're ready for the next one. So, okay, well, I'm gonna share my screen and we'll get into it. And I know we're being recorded, so I'm gonna do my best to keep things moving right along. There we go. Everyone can see that okay, right? All right, here we go. So coming up in just under a month is, or just over a month, is this very special event. Maybe some of you saw the 2017 solar eclipse, and there's another one coming along, and then this is going to be the last one for a while that cuts across our country. So if you want to see some other ones, and we'll talk about when those are going to occur, and we'll look at some maps, you will need to travel, which is not a bad thing, but this one is probably the most convenient that we're going to have in our lifetime. So hopefully there will be something for everyone in the talk tonight. I did mix in a bit of science and some of the things that I learned. I teach eclipses to my classes every year, but we only have, a class period. I generally don't go this deep. So I learned some new things that I'm excited to share, but I also have some takeaways for people who are not true scientists at heart, but are just interested in the event. And you should come away with some good things. So in general, I want to do this eclipses overview, just the different kinds that you'll see out there. And then very importantly, the phenomena attached to those. So what are you going to observe if you see either the partial or total solar eclipse? We'll go through a bit of a detailed timeline, and hopefully you'll feel prepared for what that day will look like if you're going to see it. And then I think there was a request to talk about some of the science behind eclipses. What have we learned? And as it turns out, quite a bit in the past, especially. And then I'll try to leave some time for some Q&A. And I leave it to Carol to keep me honest for time. Here we are, 7:05. Okay, so here we go. So my main premise, my guiding statement here is that solar eclipses are special for some reasons that you probably haven't thought of. Obviously, they only come around once in a while and you have to be at a specific place. But as I hope to impress on you tonight, they're extra special. They're really unique events within our solar system and possibly anywhere. So let's talk about it. First of all, we should talk about the two kinds, solar eclipses and lunar eclipses. A lot of you have probably seen a lunar eclipse at some point in your life where the moon has kind of a bite taken out of it and then maybe eventually turns red if you get totality. And that's different from a solar eclipse. So it's all about the Earth, the sun, and the moon. And in a solar eclipse, the moon is going to get in the way of the sun during the daytime and block the light and will be in the shadow if you're in the right spot. And then with a lunar eclipse, it's the other way around. The Earth is in between the sun and the moon. And so it's us. We're blocking the moon's surface. So I'm very curious that it turns red, actually. So the lunar phases, just to go through this quickly, I know we're not going to be seeing one of those, but you'll see those partial pieces and then the red moon, as I talked about. This is not phases. A lot of my students have that misconception initially, which is the monthly phases that we see, the full moon, the first quarter, all these things, they picture it as the Earth's shadow getting in the way. But it's not that at all. It's just that picture a triangle of the sun, the Earth, and the moon. If you look up, it's only going to be partially illuminated until it's on the other side of the Earth from the sun. So it's all about the alignment, and it's not an eclipse. That still is a special event, even on the lunar side of things. And then you'll notice the blood moon kind of in the middle, the reddish moon. This happens, and here's your first bit of eclipse vocabulary. In the umbra, the shadow, the main part of the shadow, it's like all the sunsets and sunrises on Earth being projected onto the moon. So the geometry has to be just right, and you'll get the sunlight beaming through there and then casting those sunrises and sunsets on the surface of the moon. I always think that's really so beautiful when I see it. And so look for that reddish moon. I was actually here in the observatory, that's where I am tonight, on the night that the Red Sox finally won the World Series back in the day. And that was also a night of the total lunar eclipse. And so I invited the whole school to come and nobody came. I just watched it myself while tuning into the game on YouTube, I think, at the time. So. And so lunar eclipses are more commonly seen because if you are on a side of the Earth that can see the moon at the time, it is going to be visible. Maybe only partially, but large swaths of the world get to see it all at once. And this is as opposed to a solar eclipse, which is the one coming for us. So just look at the diagram for a second and realize that there are these regions that get on Earth. Much of the Earth is still completely illuminated, but you might end up in the penumbra. It's kind of the partial eclipse zone, but then you'll see a tiny bit of shadow called the umbra, the darkest part, the darkest shadow, kind of a double shadow. And that's the zone that you would be able to see the total solar eclipse in. Umbra and penumbra, I love this word umbra because that's how they coined the word umbrella. If you think of it, it's like being in the shadow in the rain, being blocked. So it's kind of a blocking feeling. I really like that. So the umbra and the penumbra, and the umbra is the place that you want to be. So when we stretch that out on a map and look at it, we can find all kinds of complicated diagrams like this. There's a great site called Time and Date that I'll show you in a little bit that maps out the eclipses for the next X number of years. And we have these predictions going hundreds or even thousands of years in the future. And so you can see number one, this is the one coming for us, cuts right through the United States and a bit of Canada, and then off into the North Atlantic there. That's that path of totality in the umbra, which is the only place that you can see the total solar eclipse. However, if you're outside that, you can see the partial eclipse, which is also pretty great, I have to say. Here's a more complicated version, and you can see all the maps. Sites like NASA and other eclipse-specific sites have all kinds of maps like this, so you can really plan ahead into the future. And you'll notice, of course, the Earth being largely covered in water. A lot of these are really a good match for going out and taking a cruise. And in fact, I think there are a number of cruise lines that have their eclipse cruises, and you can go out and have a rum punch by the pool and then look out. Although I always wondered how the stability of telescopes and things like that work on the deck. I guess you need to be on a really big ship for that. So I haven't had a chance to do that myself yet, but it's on my list. Why red and blue on this map? Well, it turns out there are two kinds of total solar eclipses. One is the total, and the one that we're going to see is indeed in blue. This is a great one to see. This is kind of the main event, right? Partial eclipses here, an annular eclipse, which I'll talk about in a second, is here, but the total solar eclipse is just, it's off the charts. So the annular total eclipse happens when the moon, the moon's orbit is more of an ellipse than a circle. And so if it's a little bit further from Earth, the shadows are going to cross in such a way that you end up just getting a ring, a fiery ring around the moon, which is neat, but you can't see it with the naked eye. You got to wear those glasses the whole time. Makes for some beautiful pictures. I'll show you one in a little bit. But I have to say the total down here, where that spot, that umbra, is on the Earth and it tracks across as the Earth rotates, is the place to be. Either of those will have a partial phase ahead of it, and I'll show you some of the phenomena attached to that as we go. How are we doing so far, Carol? Everything good?
Sorry, yes, we're doing great.
Okay, great. Here we go. Just got to stick with the timing. So there you go. The partial has that kind of a bite, a chunk taken out of the sun. And then the annular on the right is that ring that I was talking about. Again, quite a magnificent sight, and amazing to think of the moon. The size of the bodies involved are just staggering. But there in the middle, that's what we're chasing after. That's what we really want to see on April 8th in the afternoon. So like I said before, you can find maps like this all over the place. I've got a set of sites at the end that I'll be able to create a list of links for that you'll have access to. And maps like this will be one of them. You can see on the outside edges, depending on how far away you are from that path of totality, the less of a partial eclipse you'll see. And so notice, here you are, if you're in the Berkshire area, you are not in the path of totality itself. However, you are getting a very nice percentage up in the 80s and 90s here. And we'll be able to look at the specifics of that. So not totality, you do have to drive for that. And I think some of you are going to. But for those of you that decide to stay at home, you'll be able to see a very nice partial eclipse. So again, just looking ahead, how often do these things occur? We're going to get into the timing of it a little bit more, but just take a look at some of the dates. The annulars, there are a couple next, and then another total in 2026. It's going to be very nice, but you're going to have to travel for it. Wow. Right through Spain there. That looks like a good one. I might have to go visit some friends over there. And then you see that it stretches out over a course of years. We'll talk about the timing and what causes that in just a minute. A couple of cool shots here. Here's a shot from space that shows that umbra, that spot. And you can kind of see the fuzzy penumbra around that as well. So kind of the partial zone. One of my favorites is the shot from the International Space Station. And it's not as defined, but they captured a beautiful area there. There are also people that have captured it from a plane. So I'll leave it muted here, but let me cut over to video. Eclipse from the plane. I'm gonna have to skip around in this one a little bit here. So here they are. Talk about a great place to see a solar eclipse. He can't really keep the camera that still, but you can see that shadow coming right for them. getting darker and darker as they're up above the atmosphere. They don't have to worry about a cloudy day at all when you're up at 30,000 feet. And eventually the plane itself is engulfed in that shadow. Everyone on the plane starts screaming and yelling. It's very exciting. You can actually see the moment of eclipse there, and they are in that umbra zone for just a few minutes. Somebody, I think, tried to take a flash photography picture, which is kind of funny, but anyway, a beautiful view of the shadow overtaking this plane. Sorry, my throat's getting a little scratchy. I'm going to take a couple sips here. So back to the premise. Solar eclipses are special, and I want to impress that on you with this list: the frequency, the location, the timing, and the phenomena that you can see. So let's start off with the frequency. How often do solar eclipses happen? A little bit of a multiple choice question here. Approximately every 375 years, that's a long wait, every 18 months or so, or could it be every month, or could we see an eclipse twice a month? We'll talk about it. So every 375 years, that occurs if you're staying in a specific spot. So say you've put your roots down, you don't want to move. How long will it take for you to see a total solar eclipse in your spot, or maybe an annular eclipse? I think that's in the mix as well. About every 375 years. Thankfully, there in the Pittsfield, Berkshires area, it's 55 years. Where will you be? May 1st, 2079. I might be, in my robotic cybernetic body. I don't know. I don't know if I'm going to see this one, but it does cut right over New England, and Pittsfield is right in the mix there. And it's actually going to start getting all of New England. Vermont is getting theirs this time around, northern Vermont. So only the southern Vermont is going to catch it next time. Again, I'll show you the site where you can find these things. So for any given spot on Earth, you do have to wait quite a while. However, if you're willing to travel, we do get this every 18 months or so pattern. And the answer is because it's really a couple cycles at play. The moon needs to be the right phase. For a total solar eclipse, it has to be in the new moon phase, which is, the back is illuminated by the sun, and we don't see it at all. The dark side of the moon, it's not dark at all, but it is the far side of the moon. We can't see it. So that's bathed in the back. And then it also has to be at a special point in its orbit. And I'll show you that in a second. And then every month, twice a month, this is if the moon didn't have an orbital tilt. That's what I was getting at there. So if everything was lined up and nice and even on the same plane, then every single month at new moon, we would get a total lunar eclipse somewhere on the Earth. And then conversely, at full moon, every single month, it would go through the Earth's shadow and you would get a total lunar eclipse. So why don't we get that? Well, the moon is at a 5-degree tilt from the Earth. So the Earth is orbiting the sun. That kind of creates a plane. And then the moon is tipped 5 degrees from that. And so this crossover point here, and also the one on the other side, are called the orbital nodes, N-O-D-E-S, the nodes. And so the moon also has to be in those positions. So you need both. You need it to be the right phase, and you need that phase to be at that node. And a lot of complicated things are happening. The whole elliptical orbit is also rotating. So a lot of very complex math has to go into it. So this is just kind of illustrating what I was just talking about. We do hit those various points, but on the left and on the right, you're not going to get an eclipse. The moon is still casting a shadow into space. It just happens to not fall on the Earth's surface, and therefore it's not going to be an eclipse. So why are solar eclipses special? Because they do happen fairly frequently, but not every single month. I think that would really ruin it. If we got to some other planet and everything was all lined up, it would just be a regular occurrence. I think it would be pretty neat, but anyway, these are special. Next up, let's look at all the other moons in the solar system. You might immediately note Mercury and Venus do not have a moon. Here we are on Earth with a huge moon comparatively. We have a moon the size of Jupiter's moons, but Earth is much, much, much smaller than the other gas giants, especially Jupiter. It's kind of surprising that we don't have moons like this. Phobos and Deimos, which are Mars's moons, very tiny. One of them is so small you could ride a bike really fast, hit a ramp, and go into orbit around the planet. And on the other, you could throw a rock and it could achieve escape velocity just with your arm strength. So it's kind of surprising that Earth doesn't have these tiny little moons and instead has a big moon like this. And that's because of the way it was formed. So it's kind of a question, where else in the solar system could we see a solar eclipse? A lot of these have a really good orbital inclination for it, right? They're quite flat. Here's Earth's moon up at 5, Phobos and Deimos, they're okay. And then a lot of these are quite flat in the plane. Some of them are totally wacky here. We can see, oh, wow, Triton and Neptune is just healed over completely. It's crazy. So most are in the plane. These two are too small, and this actually brings up a really, a different vocab word here. Let's talk about transits. They've come to use the word eclipses to mean specifically the Earth, Sun, Moon system. Everything else, when you get something blocking or going in front of the sun, we'll call that a transit. And maybe some of you remember some years ago, there was a nice transit of Venus. So we're actually capturing Venus lined up perfectly with the sun. Here's another great shot of it, multiple shots all put together. But you can have other things transit the sun as well. Some very skilled astrophotographers spend time getting things like the International Space Station cutting in front of the sun. Really beautiful, happens so quickly. You basically just hold down that shutter button, click, 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 and you capture the passing time. You really have to have everything tuned out perfectly with your mount tracking perfectly and the camera tuned up. So I have not been able to achieve a shot like this. It's challenging. And then this is kind of cool to see. I hadn't known about this. I'll show you the video in a second, but 2 of the rovers crawling around on Mars up there were able to look up at the sun and capture Phobos, one of those moons, very oddly shaped, cutting in front of the sun. So let's just see that real quick. I thought this was kind of eerie looking. Actually, while this is going, I'm going to blow my nose. Hang on one sec. Yep. Pardon the interruption. Wasn't that beautiful? You can see the sunspots and Phobos crawling across there. Lovely, but not an eclipse. That is a transit. Hit escape. And then one other one that I found that I really like. I'm used to seeing one of the moons of Jupiter in front of it and casting a shadow. That's little Io here. But imagine capturing 3 of the moons at once, one not pictured, and these 2 actually overlapping. This is a real picture. This looks kind of computer generated, but it's just because all the sunlight is facing the one side. So a couple of the big moons of Jupiter. Quite beautiful. You've got the umbra, you've got the penumbra, but not an eclipse. That's a transit. And more to the point, you could go somewhere else in the solar system perhaps, but you can't stand on those gas giants. You can't stand on Jupiter or Saturn. You can really only stand on the inner planets. And of those, we already saw Mars's moons are just too small to really fully block the sun. So right now you are sitting on the only place where you can see an event like this. And it gets even crazier than that. So frequency, how frequently they occur and how they occur, definitely make them special. And I kind of started to get into it. Our location is also perfect. I mentioned before, annular eclipses, quite beautiful. but really kind of a partial eclipse. You shouldn't look at an annular eclipse without the glasses. Kind of already covered this as well. I think this one just illustrates it a little bit better. You're really on the only place in the solar system, and maybe anywhere that we know of, where we can see this kind of event. And it's a scale thing. It's a size thing. The moon is 400 times closer to the Earth than the sun is. And the moon is also 400 times smaller than the sun. What does that mean, geometrically speaking? They look like they're the same size in our sky, which, you never really think about because the sun looks so bright, you're not really supposed to look at it. But if you've seen the moon in the night sky, it's beautiful, but it is quite small. It looks really big on the horizon. It's kind of a brain illusion. But if you want to see how big the moon and the sun really are, everyone try it now. Back away from your screen a little bit. Hold out your arm, full arm's length. Close one eye, and then look at your pinky nail, the nail on your pinky. The moon and the sun look about half that size. That seems so small, doesn't it? It does explain why, if you've ever taken a picture of the moon with your cell phone, you're probably disappointed. It's such a small amount of angular size filling up in the sky. It's also an incredible coincidence that these two are so close. Here's a little bit of math that I went to Wolfram Alpha, where you can type things in natural language, and seeing the sun over the moon just close to 400. It, of course, changes over time. I just checked again this afternoon. It was at 397, so it's changing. And then this is going to stay pretty consistent. The sun over the moon, about 400. Those two matching up mean that this spot on Earth is perfect, right? If it was any closer, then we would get more of a total eclipse, which would be magnificent, but it wouldn't line up just so. And so it's just an incredible bit of serendipity that we have that. So location, 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 how frequently they occur. They're not so rare that we never see them, but they're not so common that we're just bored of them. So timing is another issue, and I'm not so much talking about the timing of the eclipse itself, but of what we can see. Right now, 26.7% of eclipses that we see are these total solar eclipses. But far in the future, we don't need to worry about it. All of them will eventually be annular eclipses. Total solar eclipses are on a deadline. They're going to run out. When will the last one be? It's like thousands of years into the future. But the moon is slowly receding from the Earth because of these tidal forces. The tidal bulge of the water on the Earth manages to cause the force, the max force, to push the moon away at about 1.5 inches every year. Also, if you're like my students, how can we possibly know that? 1.5 inches a year? Actually, it's pretty incredible. 3 of the missions that went and landed on the moon put up these grids of retroreflectors. It's a tough word to say. Retroreflectors, that we can take a powerful laser and bounce it off the moon and get a signal back. We actually know the distance to the moon down to the millimeter level. We know the distance to the moon better than we know the depth of the oceans because of this. It's pretty amazing to me. So timing is everything. You're now in an era of time where we can see them. We see them relatively frequently, but not all the time. And we're at the right spot to stand. I hope I have convinced you that eclipses are special. And now let's talk a little bit about the phenomena of the different types of eclipses. So first of all, we've got to talk about the partial phases and then totality. And so here, Carol, is a good moment to say in a poll, which one are you hoping to see? Are you hoping to drive on your own or catch a ride with Carol's program, or are you going to stay put? So there it is. Oh, I can't vote, so you can vote. And Carol, you can end the poll whenever we seem to have critical mass.
Okie doke. It's still ticking up pretty quick, so I'm going to give people another couple seconds here.
Of course. I love the participation. It's so hard for me to teach this way. I'm just like teaching to a screen. So used to like playing off my students, and I don't know.
All right. Okay. It's starting to slow down. All right.
Get your
I'm
votes in,
gonna
everyone.
end and share.
Okay. Oh, this is great. 72 of you. Wow. Most folks are hoping to go and see this. And I think you made a really good choice. But for the 34 of you that voted that you're staying, don't worry. There's a lot of good stuff that's going to happen as well that you're going to be able to experience. So, all right, let's keep going. So here's the timeline. If you're staying in the Berkshires area or wherever you are, I'll show you the site that you can use. You will see a partial eclipse, but quite good. It's going to be on Monday, April 8th at 3:30 in the afternoon is the maximum, but it starts about an hour and change before that. So you really want to be ready at 2:10 to wear those glasses and kind of watch it if it's a sunny day. And then it ends about an hour and 10 minutes after the maximum. But a lot of people, they see the first part, it builds up to the total, and then they just kind of, let things go. But there are things worth observing in the partial phases, and I want to show you a bunch of those today. And then those of you traveling up to Shelburne, Vermont, or wherever you're going to go, we could talk about the logistics of that in a minute, but you get that added bonus at the bottom. 3 minutes and 4 seconds happens very quickly, a moment of totality. And I have to say, having seen the one in 2017 myself, it is pretty magical, right? It's pretty amazing. I'll reflect on that experience a little bit, but let's just say, as a science-minded guy, this did something more emotional to me. It was like it was more magical than scientific, I suppose. But why not both? We're going to do it with both. All right, a little bit of vocab time. We should talk about the contact points. C1 is the very moment that it starts to eclipse the sun in the partial phase. So for both parties, that's around 2:12, 2:14 in the afternoon. Then takes that hour and 10 minutes to hit C2, that contact point where it just covers everything. And then we go into that totality phase. This is the time that you're allowed to take the glasses off if you're in the zone of totality. If you're staying in the partial zone, do not take the glasses off the whole time. You are going to be tempted to, believe me, but keep them on. But if you're in totality, C2 to C3, that's that 3-minute window. And then C4 is when the whole thing is over. So you've got, this is the whole span across. But C2 to C3 are the exciting parts. There's a highlight. So here's what I recommend. Don't look down. You want to plan ahead and have this experience, and you don't want to have to be checking your cell phone and your watch. There is an app, and it looks kind of like a bee to me from a distance, but it's actually a guy talking over the eclipse. The Solar Eclipse Timer, made by a dentist who is obsessed with eclipses. And I'll show you a video from him in a little bit. It's linked in my links. He made this app for phones, and you only have to pay $1.99 if you want this specific one on April 8th. It will figure out your location, and then it will voice prompt you, and it will let you test ahead of time. It will say things like, C1 contact time, put on your glasses, and then, this is totality. So you want to get to a point where you don't need to look away from everything happening. You can just listen. And then maybe some of you can even help other people. So I recommend this one. I have no affiliation with him. I just used this one in the 2017 eclipse, and it was great. And so you can download it for free, put it in test mode, try it out. And if it seems like something you would want for the real thing, you can support the good dentist. All right, so we have all kinds of phenomena to look through. I will say that I cribbed a lot of these from that very video, and it's done by a great YouTuber, and there's a lot of good video elements. But I think these slides will sum up some of the things that you'll be able to see and have a couple of extras as well. So, first of all, as partial the partial phases happen, less of the sun will be visible, and therefore the temperature will drop. This one from 2017 from the North Carolina area had it dropping around 10 degrees. So it will get cooler. And of course, this is April. It might already be quite cool. Not that I'm worried about anybody's temperature, but you should try to notice it. And if you bring a thermometer along, you can probably observe it scientifically, but expect a significant drop in temperature. You can also expect a much more subtle effect of the wind. The direction may change. Wind is created by differential heating of the air moving around Earth, so it'll flow. And if that gets messed up by this big cold umbra moving through, you might get the wind subtly changing direction, subtly changing speed. But honestly, you probably have a hard time teasing that apart from what the regular wind pattern was. So it'd probably be a long-term weather observation for some of you super weather enthusiasts, perhaps. Clouds. If you see clouds like the one on the left, there may be some changes there as clouds will respond to the sun's heat and change. You might have seen that in an evening as the clouds kind of melt away as the temperature gets cooler at nighttime. However, if you see the clouds on the right, the overcast clouds, you should go somewhere else to try to see the eclipse. Or, if it's hopeless, I mean, I'm hoping against hope here, but, it's April in New England. Who knows what's going to happen? So I did see a nice encouragement. Go ahead and experience the eclipse instead of seeing it. If you are behind the clouds, you will still witness this darkening effect and the temperature effects. You will definitely notice that something is still happening. And so even if you don't get to see it, if we're all unfortunate and it's cloudy out, I don't want to jinx it or anything, but whatever, we can still experience this to some extent. And I'm going to try to capture a series of pictures like this, but I'm going to try to be there. I'm going to be mobile. I'm going to try to see it. One of my favorite things is these projected shadows. These are caused by leaves in the tree, kind of causing these gaps where the sunlight can peek through. And every single one of those gaps normally would be filled with light. We don't really notice it. It's, kind of that dappling on a surface, but all of them turn into a projection of the partial eclipse. So a lot of you will get to see something like this. However, I'm conscious that it's not summertime. There are probably not going to be a lot of leaves on the trees. Trees will be budding. It's April. Hopefully we'll see some, but try to go to a place, when I saw the 2017 eclipse, we were kind of out in a very flat open area, and I didn't get to see this effect at all. It would have been really cool to see it. However, if you're not near trees, there is another way. Break out the kitchen colander. If you bring a colander and a kind of plain surface, could even be just a brightly colored car, the side of a car, but a lot of people bring out like a white sheet and lay it out. By moving the colander back and forth, you could focus in and get this really beautiful array of that phase of the eclipse, and then take a picture of it with your phone. It's actually one of the better types of pictures. If you don't have a colander handy, you can bring the cheese grater. It's kind of fun. Anything with a lot of little holes like that, or even just a couple. I love this one, a Ritz cracker. You can have your snack afterward, after you see the eclipse. It's so funny to me to think of like the celestial event happening, and then the final step, the final foot is just beaming this light through a cracker. Then you can just crunch on it. So I'm definitely going to try this one. I got to think of all the foods that have little holes in them, maybe Swiss cheese, I don't know. And then if you want to be a little more scientific about it, actually, you can use your own body. Not quite the hashtag, the octothorpe, but you can make kind of a waffle pattern with your hands and then get that kind of down close to the ground and focus it. And those little gaps of light will each turn into a little partial phase. Pretty neat. And I think I'm going to try this. I have a laser cutter here at school, so I'm going to try to cut a few patterns on cardstock and hold them up. This is just with the full sun shining through, so no surprise there. But imagine every one of those dots being a tiny little partial phase of the total solar eclipse. It's going to look amazing. So the general rule is Find a plain background. You're not on some kind of uneven, dark surface. You're on a nice, bright, plain background, and then block it with something with some holes in it. Another thing that you'll notice is that shadows get a little odd. You can measure it if you want. Some people are kind of setting up these sticks, but I think the easiest one that I've seen from that same video is this kind of Y shape. I'm going to cut this out of cardboard. Depending on which way you rotate it, the thin shaft of the sunlight beaming through here is going to spill over the edge and make these top shadows very fuzzy, but then 90 degrees from them, very sharp shadows. You'll notice it with your own shadow on the ground as well. Everything starts to have kind of this eerie feel to it. I remember feeling that at the 2017 one as well. The light just has a different kind of quality to it. And you'll get that whether you see totality or whether you just stay for the partial, especially if the sun is out. If it's behind clouds, probably won't, the effect won't be as strong. Here's a way to make a little pinhole style camera. Break out a empty cereal box. Make sure you eat the cereal first, and then cut a couple of holes in the top. One of them is the one that you're going to look through, and the other one you're going to cover with tin foil. This doesn't really look like tin foil, but NASA made the video, so I'm using it. And then you just poke a little hole in it. They used a big nail there, but you can even use a smaller hole. The smaller the hole, the sharper it will be, but also the dimmer it will be. So you got to kind of like balance between the two. But then during the eclipse, you turn your back toward the sun. So the sun's shining on the back of your head, and you look through this nearer hole, and the pinhole will have the spot on kind of the back wall. So you might want to open that up and coat that with a white piece of paper. And it's a kind of fun little arts and crafts project. Might be really fun to do with any kids or grandkids in your lives. A really neat way to see the eclipse in a projection. Some people actually did, let's see, I'll hit escape here. Pinhole, camera, eclipse, box. That's kind of the nice way to do it, but I did see some people with a just a box on their head. So you can be like this guy as well, but you know, who invited them to the party? So, all right. So observe it with your own kind of pinhole camera. But now is the time to put in the plug. Go ahead and get those glasses if you've been stalling. Good news is there's still plenty out there. I just placed my order 2 days ago for 100 pairs for the people who stay here on campus, and a few screens for cell phones. So you still can get them. They're cardboard, they're relatively inexpensive, and you should wear them, the certified ones. This is eclipseglasses.com. Couldn't be easier, but I have to say, dozens, hundreds of places are selling these things. So just make sure that they are kind of certified. There's the standard, the safety standard shown there. So do not just wear sunglasses and look at the sun. Do not use smoked glass. Do not use an exposed piece of film as they had back in the day. Those certainly do knock down a certain percentage of the sunlight, but not all the harmful rays beaming directly into your eyes and causing damage to your retinas. However, NASA themselves did say that welding goggles or glasses are okay. So if you happen to have a welding mask around, I suppose you could use that. Again, you'll look a little bit unusual. All the cool kids are wearing the cardboard glasses, so you might as well grab a pair of those. Let's talk about animals. And I do have to say a caveat here, I ran this by my wife and she made a very good point that it's not really the season for the animals. But in the summer, especially if you're in a field, the crickets will feel nightfall as they feel it approaching and will really amp up and be chirping and singing along there. Bees, if you happen to be, I mean, this is a very niche thing, but if you happen to be near a bunch of beehives or your flower garden is blooming and the bees are all over the place, they will probably have a change of behavior. It's probably not one that I'm going to see this time around. And then birds as well. Birds act differently when it's twilight or nighttime, and so they might get a little confused. However, animals in general, I heard at the last eclipse, there was a woman who had cameras running on all of her farm animals, and they didn't bat an eye. They didn't care at all. It just got a little darker. It's kind of like a passing cloud, and she was disappointed. This one was new to me, the Purkinje effect. Our eyes have different sensitivities depending on the time of day and the darkness. So there it says in the daytime, the red cones in our eyes pick up more of that red color. And then as nighttime sets in, our blues and our greens come in. So colors may look a little different. This is one that I'm going to test. I'm probably not going to make this goofy 3-colored shirt, but I probably will bring out some kind of RGB cardstock and stick them out there and just see if they look any different. Maybe the blue and black dress will now look white and gold. I don't know. We'll solve that debate during the eclipse. Another cool one that I did see, and it's very hard to capture on film, so you really want to be there with your own eyes. This is mainly one for folks in totality, but I have to say in the Berkshires there, in Pittsfield, you might get a nice view of it because it's so close. These are shadow bands, or what some people call shadow snakes. Basically, the sun has turned into this very thin slot, and as it beams out on this, plain surface, some people see it on the side of a house like this. Some people just put out a big white sheet. You may see these wiggling bands of light. They might be still, they might be kind of moving around, they might be kind of slithering like snakes. This is an atmospheric effect. You're really seeing so little light that you're really seeing this kind of contrast from the atmosphere. But I tried to see a few videos of people filming this, and they could see it with their eyes, but their phone is definitely not picking up on it. I tried to capture it last time. It's really something that you just observe. So, and this is kind of right before totality and right after. So right before that C2 moment. And in fact, if you get that app for your phone, he will mention it 90, 60, and 30 seconds before C2, and then the same after, and says, observe shadow bands now. So I'm, again, going to be finding that useful. So that kind of covers the partial eclipse things that we'll all be able to witness especially if it's clear out. So we're really hoping. And so bring a couple things with you, pack a few things, or maybe as a group, kind of come up with a group package and set up a couple stations. Once you're there, you've got kind of the whole hour to observe this at all the different times and take pictures, and it's great. But when totality comes, and if you are in the zone of totality, you want to be ready. It's a very exhilarating time. What will you see? Well, if you do manage to look at the sun, if someone there has a safe solar telescope and you look in, you could see some really cool effects. The diamond ring effect is a classic one. Just as that moment happens, this is right at C2, you get that last burst of the sun. And then the moon's surface is not smooth, so the mountains and craters on the moon will give you something called Bailey's beads, or a single Bailey's bead here, where just a little bit of sunlight kind of comes in through a valley between two of those lunar mountains, and you see this kind of beaded effect. You might also see the prominences on the sun, these kind of walls of flame sticking off. If the geometry is just right, they'll be on the edge of the sun. This is something that I can see kind of any day, any clear day with a solar telescope, but seeing it with your own eyes or seeing it during an eclipse is kind of extra amazing. And then of course the corona is mentioned here. I'll just go to the next slide. This is the beautiful atmosphere of the sun, 1,000,000 degrees. It's hotter than the surface of the sun itself because the particles have room to move around, and it makes just these beautiful, iconic patterns. This is one that my wife is still angry at me for not capturing in our experience, because you have to take all the filters off the cameras. So I got some very nice shots of the partial that I'll show you, and then it just went to pure black. Why was that? Well, I was having a moment. It's amazing. I kind of got nervous. I'm trying to do the science of it, but it's a true kind of human moment too, especially if you're with a crowd. One thing you should do somewhere in that 3 minutes is look around. You get this sunset effect everywhere. The whole horizon looks like sunset. And then you do have the sun in the sky. You can still kind of see some of that light around there in the corona. And then the disk of the sun itself is darkened out. It's truly a magical moment. And I will say, people go nuts. I've seen a lot of videos of this happening. If you're in a huge place, people will cheer. There will be a lot of exclamations, a lot of excitement around that. And you want to be there for that moment. You want to experience it. So I strongly encourage you. Well, first of all, don't get blinded. C3 is coming. C2, you're on the clock. It's totality. C3 is coming, and you don't want to be staring at the sun with dilated eyes right at the moment that it comes back. Be ready. And so that's why the app is really useful. It'll tell you when to put the glasses back on. And then if you're there and you have this knowledge, but other people don't, go ahead and tell them, hey, now would be a good time to put your glasses back on. It's going to be unsafe in just a minute here. So just be aware of those times. And again, I'll show you the site so that you can dial it in specifically. Big question that I get is, should I photograph it? I have solar telescopes, I have cameras, and like I said, I kind of botched the last one. This young lady on the left, this is not really going to turn out. You know, you could try it. You could throw the glasses on the front of your camera, your cell phone camera, but at the end of the day, it's just not made for that kind of picture. It's just a few pixels in the sky, and you can zoom in. I would say sitting there and struggling to focus the camera, get the exposure right, hit, you know, the settings in your phone. Unless you know what you're doing, Lake's opinion is just experience the moment. There will be people there. Perhaps they'll be generous to let you kind of look through for a second. But honestly, experiencing the event instead of trying to rigorously capture it, you know, go online later. Everyone's going to have these beautiful pictures out there, and you can experience those later. So unless you have the equipment for it, I am going to try this time around. I do have a pretty nice camera, and I do have one of these filters that I'm going to put in the front. But I got to tell you, I'm going to spend my whole March break coming up practicing. Every clear day, I'm going to go out and kind of have it down so that I can still enjoy the moment while capturing it correctly. So. And so, speaking of my experience, let me show this. And I do have to say, this video starts with my views of the sun. It's cool. My students like it. But my favorite part of the video is actually looking back at the crowd. I put a drone up in the air and just time-lapse moded it, so it's seeing what we were seeing. And then I used a 360-degree camera to capture that sunset all around us. So let's look at this video real quick. It's pretty short. The Sunset Cafe. Oh, quick story about this. We did not make it to our destination. We were going to see it from a university in Utah, and we're coming down from the Yellowstone area, and the traffic in Idaho just got too crazy. So we pulled off at the side of the road, set up shop, and I'm really glad we did. We saw it under beautiful skies. We didn't have to fight the traffic until afterwards. So it was well worth doing. Take note. Okay, here's the video. So here are my partial eclipse views. I kind of put them all together over the course. Here it is going just about at C2, and then there's C3. So I didn't capture those minutes in between. Sorry, Liz. And then here's our observing site in time-lapse mode. And then here's the eclipse happening in that 360 camera. There's totality. And then I kind of flipped it around. Car's still driving down the road. I was like, hey, you guys should stop and check it out. Really amazing and beautiful. And just, it feels like nothing else I've felt before. It's kind of an amazing moment. And then the sun comes back and it's time to hit the road. You still have another hour of that partial eclipse happening, and you can continue to do some of those experiments. But honestly, I think a lot of people are going to be hitting the road at that time. So, okay, Carol, we are at that quick question break before I get into some of the science behind things. So, any curated questions?
So, questions related to like what kind of space people be looking for in terms of the landscape for a good spot to pick?
Great question. So you do want a clear view of the sky, but it will be high in the sky. Think of where the sun is at, around 2, 3 p.m. So a nice view of where the sun will be. But like I said before, if you're in a totally open, exposed field, you won't see some of those projection effects that I think would be really cool. Some of my favorite eclipse pictures have been those, sun through the trees type of things. But then again, if you bring everything but the kitchen sink with you, you can make your own. So yeah, find a spot. It's fun to be with people, I found. Part of me wanted to kind of be away and experience it, but that crowd energy is actually pretty fun. And sounds like a lot of you are going to go with a group. So I think you're going to have a great time.
Great. And there was a couple of questions about links to stuff. We'll send an email tomorrow with the recording of this video, and we'll include the links that Josh is going to share with me for glasses, for the app, for all of that kind of stuff. So that you can also find your place, like if you're wherever it is you're going to be, so you can get the exact timing and all that jazz.
Yep. In fact, hang on, I turned a lot of the titles into the links, but all the way at the end of the slideshow, I have a set of links, and I'm willing to, share the slideshow as well.
Oh, okay, great.
Everything will be embedded, and we'll make sure that people have those. Honestly, there's far more than I can even cover tonight, but a lot of resources out there.
Okay, great. I think mostly other questions are related to places, like how far north do people have to go? You'll be able to see that in the maps and stuff.
Yeah, and in fact, well, it's a good time. So let me show 2 resources for that. One is, I'm just Googling Eclipse Map 2024, and this second and third sites here are quite good. So let's look at this one. This is depending on the state that you're in. So if you're here in Vermont and you go up, it will show you that triple bar, the path of totality is in the middle, and that's where you would get the maximum amount of time. If you observe the eclipse right on the edge of one of these paths, it would be almost instantaneous. So the closer you are to the middle of the band, the better off you'll be, right? And so you really want to try to maximize that as much as possible and not just see it for a fleeting couple of seconds. How do you know specifically? In fact, let's try that. I'm going to go to Syracuse here in the other site. Time and Date has an eclipse. So timeanddate.com has an eclipse thing, and you can actually search eclipses by location. So I'm going to type in Syracuse, New York. And they have a special button for this specific eclipse. And then it shows, and oh, it's not bad. It's still a minute right there on the edge. But it gives you a really nice view. And in fact, I'll show this nice view for those of you, let's see, where in Vermont? Shelburne, Vermont?
Yeah, that's where we're headed.
Okay, so I'll check that one in a sec. But this has a great map view that shows this, and you can zoom in and out. It'll give you all the times over here. It'll show you what you've, kind of the percentages of the things. And so this is kind of my go-to source for eclipse planning. There are plenty of sites for them. And yeah, let me just switch over to Shelburne here. Shelbyville.
And we're hoping that we'll get there. It's possible we'll be on the side of the road.
Yep, and if you are, just, have that GPS running and you'll be in good shape. Shelburne with an E. Shelburne, Vermont. Okay, so let's take a look. And then if we click through, if we click through this, we can go down and check this out. I'll make it full screen here. So very nice little simulation that pauses. So that was right at C1. And then it's going to give me the time and the altitude in the sky. Looks like about 42 degrees up in the sky. At totality, there's C2. True totality, the maximum, C3. And then it backs off. And again, you're seeing all those partial eclipse phenomena that whole time. So really a very, very nicely done site. But like I said, there are a lot of them out there. Another one that impressed me was NASA's Eyes on the Solar System. This is useful for all kinds of things, but they have a specific page for the total solar eclipse. And you can kind of drag and watch and zoom in and go slower or rewind a little bit. and see exactly where all of these will happen, looking down on the Earth from behind the moon, see the Earth-Moon system, and see all three of them. Really impressive kind of graphics display of these things. But I know a lot of people, I think just typing in eclipse 2024 map will get you to all kinds of sites that are really useful.
So we have a question I want to make sure we answer in terms of eye safety. What about binoculars?
So you can get binoculars, but you should buy some solar film for them if you want to be viewing the partial eclipse. Be very, very careful if you're doing the total, but for the partial, hang on one sec. I happen to have in my bag a bit of solar film, so this is what I'm going to be making my, there we go. So some Botter solar film. So if you just search for solar filter film, it'll tell you the rating, and you could absolutely look through this. It blocks 99.999% of the light. So really blocks it all. Test it out on your own. It's kind of the same stuff that the glasses are made out of. It's just like a big piece that you can cut a little filter and create your own. Make sure there are no gaps, and you could safely view it that way. But I will say, apart from an eclipse situation, never ever look at the sun through binoculars or a telescope unless you know that it is a solar telescope.
And question about the sunset view. Why is it not just total darkness?
So it doesn't go to total black, in part because of that corona effect. Light is still spilling from the sun. I think if the moon was closer, we would get that complete, like, not see the hand in front of your face. But it's really because of that alignment that they're just right at 400 and 400, that they're the same, coincidentally, exactly the same size in the sky. So it's kind of that extra corona light that's leaking out over there. Great question.
Great. Okay, so it's 8:02 in terms of your timing. Do you want to
Yep.
talk some science fun?
Yes, I can be pretty quick with that as long as everyone's having a good time, and I still will leave time for direct Q&A. Yeah, I made the slides. Let's use them, right? They're pretty quick too. So I learned some pretty interesting things about eclipses in the past. I really did picture people just totally panicking and freaking out about eclipses. There's plenty of historical records about that. There was one civilization that would actually make some criminal the king during the eclipse, so that then he could be deposed and, I guess, put to death, and then the other king came back into place. How did they know these things were happening? Well, as it turns out, we've been making predictions. This is a big part of my childhood, these Tintin cartoons. I remember that being a major plot point of people freaking out. And yet our hero here knew exactly when the eclipse was going to happen. But we've been doing that for like 2,200 years, for millennia. They knew. The Chaldeans, the Babylonians knew about eclipses because of a pretty consistent series. It's called the Saros cycle, and each eclipse falls into one of these cycles that matches up with a bunch of them. It's 18 years, 11 days, and 8 hours long. So say an eclipse happened and you start the timer, or really you start marking off on the calendar like they did, 223 lunar months later, and you'll have another eclipse. They figured out that math all the way back then. And it's not always the same cycle. It really depends on the lunar orientation, but it's like the time that the clock resets. So this was the 2017 one that we had. The next one in that cycle is at 2035. But then the one that we're about to see is cycle 139. So they just call them solar Saroses, and there are the lunar ones as well. You can see 132 is down here. I found this to be quite hypnotic, this little animation here showing, obviously the Earth is spinning, and that's why it's occurring in different locations. But there's kind of a complete loop of this cycle. And when they match up, you get an eclipse. So all of them can get categorized into that. Something that I studied in college in a class called archaeoastronomy was kind of an amazing discovery. Oh, I think I already mentioned this to you. To get an eclipse, you need either the new or the full moon, and then you have to be at that orbital node of the moon. So again, that 18-year cycle. They found this device off of Greece called the Antikythera mechanism, Antikythera, I think it's pronounced, but I always like to say Antikythera. 2,000 years ago, they made this mechanism. Since I was in college, whatever it's been, 25 years, they have figured it out. It was this incredible device, essentially like a computer 2,000 years ago that used gears. And on the one side, you've got all the planetary stuff, but on the back, on the bottom was this spiral pattern that is exactly this eclipse prediction cycle. 223 of those in a spiral, and then the cycle repeats. Completely brilliant, really amazing. So people have made working prototypes of this. There it is, a piece from the thing itself. Epsilon Kappa Rho is that 223 months in ancient Greek. People, of course, have made simulations of it, and we can capture this one online. You can see the dials moving. And it looks like we've got an eclipse coming up in the lower right there. That's the spiral. Here it comes. And this is our eclipse. This is the one that we're going to see. Really impressive. So feel free to tune into that channel if you want. It's amazing that people have figured that out, though. Speaking of, well, so that's kind of on the prediction side, and I'm going to come back to predictions in a second. But the eclipses also led to discoveries. So in 1868, there was a solar eclipse seen in India by a couple of people that didn't even know that they were competing. Jules Janssen from France, Norman Lockyer from England were astronomers, yes, but looking at the spectrum of the sun. If you split the sunlight into a prism, you'll get these patterns, either these absorption lines, these kind of dark lines across the rainbow, or these emission lines where the sun is giving off just that one element. This is kind of like the fingerprint of chemicals. And they knew from the lab, they would burn these chemicals and then look through the spectroscope and see these lines. And they saw something surprising, a mysterious yellow line. And it wasn't the sodium line that they thought. You've seen a sodium arc lamp before. It's kind of very yellowish. But this was off a little bit. And so does anyone know? A new element was discovered and coined. Put it in the chat if you know, maybe there'll be a prize. The element was helium, named after Helios, like the sun. So this second most abundant thing in the universe, helium on the periodic table, number 2, the sun is burning hydrogen into helium with fusion. Burning is not the right word, but and it was discovered in the sun first before we were able to find it and extract it here on Earth. Really cool side effect of an eclipse. But probably the most famous one is Einstein. Einstein's theory of relativity is quite surprising, and many of his fellow scientists at the time thought that he was way off track. It made some incredibly bizarre predictions about time slowing down and length contracting and relativity. Science fiction, it felt like it at the time. But it made a prediction, basically that mass can bend light. So the light from stars, which we normally can't see during the day, but we absolutely can during a solar eclipse, is bent. And that means you would look for a star in where it should be, its normal location, and it would actually look like it's in a different spot. So Arthur Eddington set up 2 different expeditions, and he went on one to West Africa and to Brazil to witness the solar eclipse in 1919. There he is with Einstein, and here's his set of equipment, a lot of complicated stuff to be able to make this observation. And sure enough, nailed it. Einstein got it just right. The predictions were true. motion, the apparent movement of the stars, not movement, but displacement of the stars, happened just the way that his theory predicted. And boy, they certainly write New York Times headlines a lot more tersely these days, but lights all askew in the heavens, men of science more or less agog over results of eclipse observations. So a lot of hype about this. This is how a generation, it only took a generation for people to realize that he was correct. And since that time, special and general relativity have been shown to be, they work every time to make predictions that are correct. In my mind, that's really the true power of science, to kind of come up with the ideas and the laws and then put them to the test. And those tests come true. That power of prediction really validates the theory. So really impressive. And so with that, enjoy the eclipse and please wear those glasses, get those glasses. I have no affiliation with the glasses company. I wish I did, because I'm sure they're doing a lot of good business these days. And finally, thanks for coming. Are there any questions? And there's the set of sources that I will pass along. So with that, I'm officially done.
All right, thank you. So
Sure.
let's go back and just take a peek and see if we missed any questions, and folks can add new ones in while we're
Please
doing
do.
that. Oh, there was a question back when you were showing the not totality, oh my God, not when it goes across, it begins with T. What's the word?
The transits, yeah.
Transit. I was like, transverse? No, the transit on Mars. So that was the shape of the moon is irregular, right? But it
Yes.
moved across like without changing how it was wobbly. How does that work?
Yeah, because it's in orbital lock. So it's as it rotates through, much like our own moon, we only see that one side of the moon because it's in orbital lock with Earth. So it rotates once for every revolution. The moon's year and day are the same length of time, about 27 days, right, to do one rotation. So in a similar way, it's kind of the nature of the gravity of the situation. They're not spinning on their own because that would take more energy than just always facing that same side. And so that's why it kind of looked a little, maybe a little artificial, looked a little odd, right?
Okay, great. And how many miles wide on average is the path of totality?
Oh, good question. Looking at the map, that's the kind of thing, path of totality. It does change depending on the eclipse, so we can check in miles of the 2024 eclipse. And do we just trust the Google? 115 miles wide. No, that's the whole. Oh no, I guess it is. Yeah. So that to me feels like a pretty wide one. This one, national eclipse here. I guess I trust them 120 miles wide. Let's see. Yeah, so 60 miles between the center line and the edges, but 120 miles across. Pretty good.
Oh, and somebody had asked where you are taking students to see
Oh, yeah.
the eclipse.
Right. So we are going, let's see, solar eclipse map. I just want that interactive one. But that's the one where we're heading out toward Rochester, New York. But then we are going to try to see. There we go. We're staying right here at Lake Keuka, the Y-shaped one. And then we're just going to try to head straight north. So rather than coming over here to Rochester where totality is, we're going to try to come kind of in here. So hopefully this road will be okay. And then we'll just be able to head on home out of there. I guess I will say I was saddened and very impressed with the volume of traffic out there in Idaho. I have to imagine here in New England, it is going to be a zoo. So I would say pack your snacks or try to stay over. I know your group going up to Shelburne will be on the road. Be ready for a crazy amount of traffic. But then if you have a way of staying up there both the night before and the night after, your life will just be a lot less stressful.
Hmm. There was a question about, is Plattsburgh, like which side of Lake Champlain, does that matter?
Nope, you're basically going to get the same experience. There's really no bonus for going directly on the line of totality because it's a matter of seconds extra, which you would never notice if you're really doing it right. You know, if you're timing the thing, I guess. But I think that there are going to be people who are insistent on being right on that center line, and therefore it's going to be all that much more crowded and probably frustrating. So I would
Mhm.
say be a little further away from the center line and have a better time.
And then somebody asked that they read or mentioned they read that a comet might be visible during the eclipse. Have you heard anything about that?
No, although I do know that there is a comet around. Let's check because that'll be something. Oh, the devil comet. Uh, I don't know about that. It is from Business Today. Yeah, I
Aren't
guess
they
I'm
the
gonna look at that.
leading astronomy magazine?
Yeah. Yes, that and Outlook India. Yeah, no, I don't know. An exploding green devil comet. Boy, people certainly love to hype all things astronomy. Not that I know of, but I will look further into the devil comet and send it your way.
Okay, great.
All right.
Do solar eclipses influence or cause modifications in flight schedules or weather equipment? Are there any sort of like solar flare style things that happen?
No, if anything, we're more blocked than we usually would be.
Oh, right.
In a way, it's kind of better for us. But then again, the coincidence of that, you know, the thing that we really need to worry about is a CME, a coronal mass ejection. I'll pull that up. A CME from the sun. The sun just disperses this huge amount of energy that rockets out. And if we're kind of near it, we get beautiful northern lights. But I have to say, if the timing is such that it hits the earth directly, that's the one that they talk about knocking out all of the power grid and, you know, just the world turning into chaos. So it's not very predictable. The solar activity cycle in general is predictable over 11 years. But anyway, not really related to eclipses because that's purely a function of the moon in its orbit around the earth. And the sun is still, you know, millions of miles away there. So
Mm.
93 million miles away.
So there was another question about binoculars. So would, if you were to use, so you put the little black screen things on, right? And then if you use them, what does that buy you, like in terms of what you can see versus just the naked eye?
So you'll see it a little bit closer if you have a decent, you know, a really good, decent pair of binoculars. But then again, it's that partial eclipse, and you really want to make sure, I guess, get ones that have that rating, because I know you are increasing the amount of light coming in. And then during totality, I guess, yeah, in my position, I am mainly recommending the glasses and
Mhm.
witness it with your own naked eyes. Um, some people do this projection thing, which I think is pretty great. You can shine it down. Let me see if I can pull this up more. This is talking about using them to safely project it, but then you wouldn't want to be looking through it at the time.
Oh,
So,
okay.
yeah, I guess I'm not going to recommend that people look directly at the eclipse with binoculars. The solar film would make me feel much more comfortable about that, but
Yeah. Okay, great. Um, oh yeah, for people who wear glasses themselves, like can you just sort of squish the
yep,
cardboard things around them?
they pop right on top of it. And yeah, exactly. Yep, put it on either side, inside or outside. I'm guessing outside, you know, like they usually make them so that there's kind of a loose fit and you can kind of pull them out. And if you want to get there, fancy ones that are more like wraparound and things like that. But then again, this is focused at infinity. So it's like way, way out there. Yeah, I don't know. With vision, is the sun normally blurry for you? I don't
I
know.
don't know.
Yeah.
Right,
Um,
there'd be no way to know because you never look at it.
that's true. You're really not supposed to. But can you see the moon clearly? That's a good one.
Yeah.
If the moon looks like a fuzzy dot, then keep the glasses on and put the solar glasses on in the front of that. Yeah.
I have to say the ones that we got for the Ollie trip, I did try on in the office today to make sure that they like worked. And I put them on over my glasses. It was fine.
Great. And did you go out and look at the sun?
No, I looked at a plant light, like a,
Well, go out and look at the sun. Like if you get these solar glasses, go ahead and look at the sun anytime. It's pretty interesting to see because it really is the size of the moon and it's just sitting there like this orange disc. So you can really use them anytime. It's not just for eclipses.
Awesome. All right, great.
I wouldn't make it part of your permanent fashion catalog, but
Fair. All right. It looks like our question pace has slowed down some here. I know we didn't get quite to all of them, but we probably should let you wind up things here. Here, let me just put my face back on so you're not looking at nothing. Hello. Josh, thank you so much for spending time with us tonight and walking us through this. This was really fun. And I had myself muted so I didn't ruin everybody's night, but I was laughing a lot.
good. Laughing at me, Carol. I'm so offended.
No, with you at your
Just like
at
the
your
old
quality
days.
jokes.
Yeah. I was throwing out the jokes and hearing no response. I was like, I'm really bombing here.
All right, great. Thank you so much. Be well, everybody, and be safe out there.
Yep.
Don't look at the sun directly.
See you April 8th.
All right, take care, everyone. Good night.
Right.